Hi, welcome again. Welcome you all in the lecture number 5 of Engineering Mathematics 1 MTL 1025. In this lecture, we will discuss some results based on the Euler's theorem, right? And some numerical example based on this deduction formula, right? In previous lecture, we already discussed what is homogeneous function, what is Euler's theorem on homogeneous function, and some result derived from the Euler's theorem, right? Now let us see one more deduction, that is deduction number 2 using Euler's theorem. What is deduction number 2? Which it states that what is u? That u is some function of xy. Note that I am not saying that u is homogeneous function of xy, right? Now what is deduction 2? x2 del 2u by del x2, 2xy del 2u del x del y plus y square del 2u del y2 is equal to gu g dash u minus 1. What is this? G dash u minus 1, right? We have to prove this deduction. Now one thing is unclear. What is gu? Gu is n into f of u f dash u. What is gu? N into f of u f dash u, right? Now based on deduction formula 1 that we already discussed in the previous lecture, that x del u by del x, y del u by del y is equal to n into f of u f dash u, which we call it gu, right? Now say this deduction formula 1 is as equation number 1. Now differentiating 1 with respect to x partially. What is that? See, differentiating this equation with respect to x partially, what we obtain? X del 2u by del x2, right, plus del u by del x, right? If we differentiate, then we obtain x del 2u by del x2 plus first function x derivative of second function del u by del x plus second function del u by del x, and derivative of x is 1, plus y derivative of del u by del y is del 2u del x del y, right? And what is derivative of y? That is 0. This is equal to gu, that is g dash u, derivative of right hand side, right? Derivative of gu g dash u, and what is derivative of u? Del u by del x, right? To this derivative del u by del x, right hand side, del u by del x, right? Then after simplifying above equation, we got this, nothing but take common del u by del x, we obtain right hand side as this form, left hand side remains as it is. This is equation number 2. Now differentiating this term 1, equation 1 partially with respect to y, right? What we obtain? X del 2u del y del x plus del u by del x, and derivative of x is 0. Now y derivative of del u by del y, del 2 by del y plus del u by del y is equal to g dash u del u by del y. Now after simplifying, we obtain x del 2u, either del y del x or del x del y, both are same, del x del y plus y del 2u del y2 is equal to g dash u minus 1 del u by del y. This is equation number 3, right? This one is equation number 3. Now what we have to do? Multiplying equation 2 by x plus equation 3 by y, right? We obtain this deduction, whatever we have to prove, right? Multiplying 2 by x and 3 by y and adding them, we get the required result, right? See some problem, right? Based on this deduction formula 2, let us consider one example. If u is equal to tan inverse x cube plus y cube divided by x minus y, right? This u is not homogeneous. This u is not homogeneous function. Then what we have to do? Convert this term as follows. Tan of u is equal to x cube plus y cube divided by x minus y. This tan u is homogeneous function. Then apply Euler's formula on tan u, that is x del y del x of tan u plus y del y of tan u is equal to n into tan u. What is n? N is equal to 2. And this function is homogeneous function of degree 2. Homogeneous function of degree 2. Right? What is derivative of tan u? Sec square u. Right? Then this term can be written as x del u by del x plus y del u by del y is equal to 2 tan u divided by sec square u. Now simplify this term. This is equal to 2 sin u by cos u into cos square u. This is equal to 2 sin u cos u is equal to sin 2u. Right? Now we obtain this equation 1. Right? Now what we have to prove? That we have to prove second part. Right? What is second part? Ex2 del 2u by del x2 plus 2xy del 2u del x del y y2 del 2u by del y2 is equal to 2 cos 3u sin u. Right? Now see, first part is okay, right? This we already proved, right? This term was repeated from the previous slide. This part we already proved, equation 1. Now consider gu is equal to, or apply, if we want to apply deduction 2, then we know what is gu. Gu is equal to sin 2u, right? If gu is sin 2u, then what is the deduction? Deduction says that x2 del 2u by del x2 plus 2xy del 2u by del x del y plus y2 del 2u by del y2 is equal to g of u g dash u minus 1. Right? Now left hand side is okay, but right hand side is gu. What is gu? Sin 2u. What is g dash u? Derivative of sin u, sin 2u, right? Derivative with respect to u, that is 2 cos 2u minus 1, right? Multiply this term, 2 sin 2u cos 2u minus sin 2u. This is 2 sine A cos B, that is sine A plus B means sine of 4u, and minus sine A minus B, that is 2 sine theta cos theta. 2 sine theta cos theta is equal to sine 2 theta, that is sine 4u minus sine 2u. Right? Apply the formula of sin c minus t. Sin c minus t is 2 cos c plus t by 2. 2 cos c plus t, 4u plus 2u by 2, that is 6u by 2, that is 3u. Right? And sin a minus b by 2, 4u minus 2u by 2, that is 2u by 2, that is sin u. Right? This is the right hand side. Now, this result will be deduction formula 2. Similarly, this is for your exercise. What is that? This u is not homogeneous. Then again, sine of u is equal to x plus y square root of x plus square root of y. Right? This is homogeneous function of degree 1 by 2. Homogeneous function of degree 1 by 2. Right? We have to prove that this thing. What is this? Now, apply Euler's formula on sin u, means x del by del x of sin u plus y del by del y of sin u is equal to 1 by 2 sine of u. Right? Then this gives x del u by del x, y del u by del y is equal to 1 by 2 tan of u. Right? This thing, equation number 1. Now, apply deduction 2. If we apply deduction 2, then we consider GU is equal to this. What is GU? G of u is equal to 1 by 2 tan u. Right? Then what is deduction? Deduction is that x2 del 2u by del x2, 2xy del 2u del x del y plus y2 del 2u by del y2 is equal to g of u g dash u minus 1. What is gu? 1 by 2 tan u. What is g dash u? 1 by 2 derivative of tan u is sec square u minus 1. Right? After simplifying this, we got this term. Right? You can verify it. Till now, whatever we have discussed, that is the partial derivative. Now, come to total differential. What is total differential? We have already discussed, if f is function of two variables x, y, then what is partial derivative? That is del u by del x. Del u by del x basically means, what is the limiting definition of del u by del x? Limit u means f of xy, limit delta x tending to 0, f of x plus delta x treating y as constant minus f of xy divided by delta x. Means, what it means, when we are differentiating any function of two or more than two variable with respect to one variable, then we treating one variable as a constant. Right? See here, we are differentiating u, that is fxy, with respect to x. Then we are changing in partial derivative only x variable while taking other variable as a constant. Right? This is the definition of partial derivative. What we are doing in total derivative? In total derivative, if function is two or more than two variable, then all the variables x, y or x, y, z, right, all the variables varies, right, with a small increment, right? Then that is x change with x plus delta x, y changes with y plus delta y, and taking limit delta x delta y tending to 0, right? See here, in partial differentiation of a function of two variable or more than two variable, only one variable varies in partial derivative, but in total differential, increment given in all the variables. It is important. Increments given in all the variables, right? Increment given all the variables, but here increment given only in one variable, right? This is the PD, partial derivative, and this is for the total derivative TD, right? See, if z is function of xy and delta x delta y is the small increment in x and y, and what is delta z? If we change x and y within a small increment delta x and delta y, we obtain a small change in z, that is delta z. Then z plus delta z is equal to f of x plus delta x, y plus delta y, right? Now what is delta z? Z plus delta z minus z, right? Z plus delta z minus z, that is, what is z plus delta z? Z plus delta z is f of x plus delta x, y plus delta y minus fxy. This is del z. Now subtracting this term and adding this term, right? Subtract this term and add this term from above equation in this equation, right? And taking limit delta x delta y tending to 0, we obtain dz. Taking limit delta x tending to 0, delta y tending to 0, we got dz is equal to del f by del x, right? This is the derivative of partial derivative of f with respect to x, del f by del x dx, and del m by del y dy. This is called total derivative of z. Now consider one more result. What is z? Z is the function of xy. And what is x and y? X and y are function of t, right? If we represent this by graph, what is z? Z is function of x and y. What is x and y? X and y are function of t. Now what we have to obtain? Total derivative of z with respect to t, dz by dt. See all the path from z to t and add them. Now there are two paths from z to t. One is z to x and x to t, and another path is z to y, y to t. Then we have to, what we have to do? Del z by del x, del z by del x, since z is function of two variable, and dx by dt, dx by dt, since x is function of only one variable t, del z by del y and dy by dt, right? This is the definition of function of two variables, and two variable is the function of single variable t, right? See another remark. If z is function of xy, what is z? Z is the function of xy, right? What is xy? Xy is function of uv, that is, see the graph, z is the function of x, it is function of y. What is x? X is the function of u and v. What is y? Y is the function of u and v. Now what we have to obtain? Del z by del u. See all the path from z to u, right? How many paths from z to u? Z to u are two paths. One path is z to x and x to u, and another path is z to y, y to u. It means what is del z by del u? Del z by del u is equal to del z by del x by del u, right? Don't say that del x by del x is cancel out, right? This is big statement. Del z by del x and del x by del u. Now del z by del y plus del y by del u, right? Similarly, del z by del y, v is equal to del z by del x. There are two paths from z to b. One is z to x and x to b. One is z to x and x to b. Another one is z to y, y to b. Means del z by del x by del v plus del z by del y by del v. Right? Okay. Now see the example. What is u? U is equal to x cube plus y cube. And what is x? X is a cos t, b sin t. Now we have to find out du by dt. See, what is u is the function of x and y. And x and y are the function of t. What we have to find out that du by dt. What is du by dt? Del u by del x dx by dt. Right? Plus del u by del y dy by dt. Right? Now see, del u by del x. What is del u by del x? Del u by del x is equal to 3x square. And what is dx by dt? Dx by dt is minus a sin t plus del u by del y is 3y square. What is dy by dt? That is b cos t. Now putting the value of x a cos t and putting the value of y b sin t. Simplifying this, we got this term. And this is equal to du by dt. See another example. What is z? Z is the function of x, y. What is x? X is function of two variables, u and v, right? Then we have to find out, we have to evaluate y del z by del u, x del z by del v is equal to this, right? See, what is z? Z is function of x, y. What is x and y? U and v. U and v, right? Then del z by del u. What is del z by del u? Del z by del x, see the diagram, del z by del u. How many paths from z to u? One path is z to x, that is del z by del x to u, del x by del u. Another path is del z by del y and del y by del u, right? Del z by del x and del x by del u is equal to this. Del z by del y by del u is equal to this, right? And this is equal to x del z by del x. What is this? This is x. What is this? This is y. X del z by del x, y, this one is x and this one is y. X del z by del x, y del z by del y, right? Now y del z by del y, del z by del u, this is equal to del z by del u. Now multiply this equation by y, right? Multiplying this equation by y. Y del z by del y is equal to xy del z by del x plus y square del z by del y, right? This is equation number 1. See, this is equation number 1. Similarly, x del z by del y is equal to this term. Now adding equation 1 and 2. Adding equation 1 and 2, we got this term, right? We got this term. Now del z by del u we already evaluated, right? This one. Now squaring and adding these terms, squaring this term both side, squaring this term both side, we got this term, right? And squaring this term, we got equation number 4. Now adding equation 3 and 4, we got this. Okay. In this, we already discussed when one function is function of one variable, function of two variable, that is z is function of xy and xy is function of t or function of uv. This type of total derivative we already discussed. Now see another kind of example. See, if u is equal to function of y minus z, right? Z minus x, x minus y, then we have to prove that del u by del x, del u by del y, del u by del z, sum of these three terms is 0, right? What we have to do? Let us introduce three new variables. R. What is R? R we consider y minus z, S we consider z minus x, and T we consider x minus y, right? What is U? U is the function of R, S, and T. What is R? R is the function of y and z. What is S? S is the function of z and x. What is T? T is the function of x and y, right? Now see how we evaluate del u by del x, right? Del u by del x. See how many paths are going from u to x. Consider all these paths and add them. See, one path is from u to s, s to z, and another path is u to t and t to x. This can be written as del u by del r and del r by del x. If you want to write this term, then it is okay. Otherwise, it is immaterial. Why? Since r is not function of x, therefore del r by del x is automatically 0. Right? That's why we have written here del u by del r multiplied by 0 plus del u by del s into del s by del x. What is del s? Del s by del x is minus 1, means del u by del s into minus 1 plus del u by del t plus del u by del t into del t by del x, that is 1, right? This one is 1. Now this term is 0. This term is del u by del s. Equation 1 gives del u by del s minus plus del u by del t. Similarly, we can obtain del u by del y and del u by del z, and adding all these three terms we got 0, right? You can check it, verify it. If you have any problem, then you can ask me. Similarly, consider another example. What is u? U is function of x minus y divided by y, z minus x divided by xz. Now x by xy is, see, this is r. What is r? R is equal to x by xy means 1 upon y minus y by, that is 1 upon x. And what is s? S is equal to 1 upon x minus 1 upon z. This is r and s, right? Now we have to consider x del to u by del x2. One term I have to evaluate it. U is the function of r. U is the function of r, and del u by del x, del u by del r by del x, del u by del s, del s by del x, right? What is del u by del r? I don't know. Now what is del r by del x? What is r? R is this term. What is del r by del x? 1 by y is 0, minus 1 by x is 1 upon x square. Now del u by del s, what is del s by del x is minus 1 upon x square. Now multiply x square by del u by del x. X square del u by del x is equal to this term. Similarly, y square del u by del y is equal to this term, and z square del u by del y is equal to this term. Add this term, and this term, right? We automatically get right hand